Hey everyone, it's Mr. Canfield. Today we're going to be in chapter 2, 2-1, and this is called Parallel Lines Cut by a Transversal. Let me see what the actual title is, because this is what I'm calling it, because this is what we're really focusing on. Let's see if they've got a fancier or less fancier, ultra fancy title. No, they just call this parallel lines, but we're really focusing on parallel lines that are cut by a transversal. So let's talk about what that is. I'm going to be drawing my notes by hand today. I'm realizing, especially with geometry, you got to be drawing it and thinking about it for it really to be at all meaningful. So grab your ruler. And I was at the dollar store last night, and they had these things called glass pens. It's a pen with a little inkwell, and you dip it, and oh man, it's so fun. So anyway, we're gonna start out. We're gonna draw two parallel lines. So to make life easy, I'm just gonna use one side of my ruler, and then the other side of my ruler. There. So like, those are definitely parallel lines. So just a reminder, parallel means that the two lines never touch. No matter how far they go, they will never touch. If you remember slope stuff, they have this exact same slope. And we actually can draw a little arrow on it. That little arrow indicates, hey, this line and that line, even if they don't look like it, they are parallel, they will never touch. All right, then we're gonna grab a ruler, throw some random, drop it down. This line is called a transversal because it transverses both of them, it crosses them. All right, and we are going to label our angles. I clicked away from my notes. I want to make sure that I go through everything in our notes today. So I've got my notes on my computer screen just to make sure I cover all the important pieces. All right, where'd they go? Okay, so and what we're going to do is we're gonna label each of these. You label them however you want, but I mean, just do what I do so that when I'm talking about them, I'm making sense. We'll call this one 1, then 2, then 3, and then 4. But there's also four more down here. So we could call this one 5, then 6, then 7, then 8. And if you're wondering why I'm doing this order, like I would do 1, 2, 3, 4, and then 5, 6, 7, 8. I don't know why our book did this order. Really, really confuses me why they thought this would be a 1, 2, 3, 4, and then blah, just jump around all sorts of places. Okay, so it's important for you to look at this and see if you see any relationships or anything interesting. Well, one thing we already know, right? It's the beginning of the problem, but we already know angle 1 and angle 3, those are identical, right? So then 2 and 4 are also identical. Do you remember what those are called? We had a special name for that. They were called vertical angles. So I did a single arc to show that 1 and 3 were the same. I used a double arc to show that 2 and 4 were the same. So this guy here, this is called a transversal. So, and then we could say, well, 1 and 3, we could say angle 1 equals, well, we got to use the geometry equals, we got to use our congruent sign. Because vertical angles. Okay, so we got that. 1 and 3 are equal because they're vertical angles. So are 2 and 4. So what else? Well, down here, 5 and 8. And 6 and 7. All right, that's what vertical angles means. Just anytime they're across the vertex from one another, they are equal to each other. We proved that in class one day, and you never have to prove it ever again. We're allowed to use that forever because we know it's true, because it's been proven to be true. All right, so there's that. Now, let's see where we go from here. So are you noticing, so I didn't put markings down here. Are you noticing anything about these angles up here versus these angles down here? For instance, look at angle 1 and look at angle 6. I wonder if there's some kind of relationship there. So, something that I'm going to tell you is that 1 and 6 are called corresponding angles. So, let me move up a little bit. So, So 1 and 6 are called corresponding angles. And do you have a guess yet? 1 and 6 are actually congruent. They're the same measurement. So 1 and 6 are congruent. All right, let's talk about what else are corresponding angles? We have 4 sets of corresponding angles. So 1 and 6 are corresponding. 4 and 8 are corresponding. Let's see, what corresponds with 3? 7. See, it's the angle that's in the same spot, like top left, top right, bottom left, bottom right, top left, top. So 3 is the bottom right. It goes with the bottom right there. So that's 3 and 7. And then yawn and yawn, pardon, excuse me. So 2 and 5 would be our last 2 corresponding angles. Cool. So you might notice that I'm taking notes on blank paper. I find, for me, I like drawing pictures when I take my notes. I like being able to kind of freely write wherever I want to instead of being limited by lines. So that's why I'm using these. Okay, let's keep going. So that's something that's always true no matter what. So like, if you don't believe me, that's fine, but I'll draw 2 other, here's a parallel line, here's another parallel line. And I'm gonna try to cut with a very, very different transversal this time. So check it out. So that angle and that angle, those are vertical angles and they're the same. But if you notice, they're like the left and right ones. Down here, the left and right ones would also be that exact same measurement. That's one of those things, if you like were to fold your paper up and kind of lay them on top of each other, you would see just how exactly perfect they are. Hold on, I'll grab some scissors really quick. Yeah, scissors, right? There's the one, here's the other. So if you lay those on top of each other, you can kind of see how exactly the same they are. They really are exactly the same. Those angles are perfectly identical. Sure, my drawing might not, the way I drew my arcs might not be perfect, but the way they line up is perfect. So it's pretty cool. So I gotta move on to a couple pages down. I pressed down kind of hard with my box cutter there. All right. So, real quick test. Make sure you understand the words here. All right, I got these 2 parallel lines. If I missed by a little bit, it's okay. But let's just say those are parallel, and let's cut, just picking a random transversal. So like if I was gonna label these just for me and my own thinking, I might even call this one the way that but let's say 1, 2, 3, 4. Well, if I started with 1 at top left, I would call this 5, 6, 7, 8. Personally, that makes more sense to me. But we're just naming it. There's no like importance about that. So what corresponds with 3? Well, 3 is the bottom right, so that means that 7 would correspond with 3. And we could say, well, 5 is also equivalent. It's not a corresponding angle, it's got a different name, and we'll talk about that in a minute. But so 3 and 7 have the same measurement, and so does 5, and so does 1, right? So 1 and 5 are corresponding, they're equal to each other. 3 and 7 are corresponding, they're equal to each other. 1 and 3 are called vertical, they're equal to each other. 5 and 7 are vertical, they're equal to each other. So 1, 3, 5, and 7 are all the exact same angle measure. That means 2, 4, 6, and 8 is a different angle measure. So my curiosity here is, well, what would that angle measure be of 2, 4, 6, and 8? It's an interesting question. I'm just gonna float it out there. Like I'm gonna pick a random number. Let's just say this is a 65-degree angle. I don't know what it is, but if 1, 3, 5, and 7 are all 65 degrees, what would 2, 4, 6, and 8 need to be? And I'm just floating it out there. I'm not answering that right now. I just think it's an interesting question worth thinking about. Okay, so let's move on to our next bit of vocabulary. I'm just gonna keep on drawing different ones. You really could stick with the same picture most of the time. So if you don't have your, if you don't have a ruler, that's fine. You can still do this. Like just draw 2 and then slice it, right? It's okay if it's a little bit wobbly. Let's talk about this phrase, alternate interior angles. All right, alternate. What does alternate mean? There's a couple different ways that we can think about it, but alternate means like switching or like every other kind of thing. It's something's alternating, it's changing. So we're just going to focus on these four. I'm using A, B, C, and D just to switch it up a little bit. We could call them 1, 2, 3, and 4 if that'd be good, or however you want to label it is really fine. But in this situation, we could call angle A and angle D. Those are alternate interior angles. I'm just going to say AIA to save me some writing right now, but these are alternate interior angles. So what makes you think they're alternate and interior? Oh, well, let's see. They're in between those two lines, and one's on one side and one's on the other side. And if you remember from what we were talking about before, well, A and this one over here, which I didn't give a name, those are equal to each other, and this angle and D are equal to each other. So that means that A and D are actually equal to each other. So alternating interior angles are actually equal to each other, or congruent to each other. And if we look at this, well, that means that B's got a vertical angle right there, and that angle matches up with C down here. So B and C are also alternate interior angles. And B and C are also congruent. So these things called alternate interior angles are congruent. So you might be surprised to learn there's also something called alternate exterior angles. So I'm going to draw another situation, or even the same situation. I'll switch back to numbers. I don't want to be too confusing. So 1, 2, 3, 4, 5, 6, 7, 8. So if we were talking about alternate interior angles, we could say 3 and 5 are AIAs, and 4 and 6 are alternate interiors. So what do you think alternate exteriors would be. Well, alternate exteriors are just going to be just like the last time where they were on opposite sides of the transversal. Alternate exteriors are going to be on opposite sides of the transversal, but they're going to be outside of the parallel lines. So like 1 and 7 are going to be alternate exterior. Well, what's the case with those? Well, I know that 1 is congruent to... Is 1 congruent to 7? Well, let's see. We know that 1's congruent to 3. We also know that 1's congruent to 5, right? We know 1 and 3 and 1 and 5 are congruent. Are either of those congruent to 7? Well, 3 and 7 are what we call corresponding, so those are congruent. Oh, okay. Oh, okay. So 3 and 7 are corresponding, so they're congruent. Oh, wait, 5 and 7 are vertical, so they're congruent. So yeah. Yeah, so 1 and 7 are congruent. Lo and behold. You might not be surprised. So alternate exterior angles are also congruent. So alternate interior angles are congruent. And alternate exterior angles are congruent. Okay. Let's see what we're going to talk about next. So these are language that we will see. We'll talk about alternate interior, alternate exterior. Those are phrases that we'll see used. All right. So we talked about alternate. What about when they're on the same side? So I'm going to go back to use my ruler. I feel like, man, this ink is getting messy. Yeah, I wonder why people don't use pens like this all the time. Additionally, I spilled some. Oh my goodness, it's too fun though. I'm gonna keep on using it. I'll clean it up after I'm done the video. I feel like I'm like in ancient times when they, well, not even ancient, just a couple hundred years ago when they had to use like a quill and an inkwell. All right, let's see. So what if now, 1, 2, 3, 4, 5, 6, 7, 8. What if now we were looking at, instead of alternating angles, so like 3 and 5, what if we looked at 3 and 6? Are they actually equal to each other? Well, if you remember, 3 and 1 are the same, 5 and 7 are the same. 6 and 2, those are corresponding, or 6 and 4, those are alternate interior. 3 and 2 add up to 180, right? They're different angle measures because it's a straight line. Well, that means that 3 and 6 add up to 180. So 3 and 6 are actually not equal to each other. So they are supplementary. So same with 4 and 5. 4 and 5 would add up to 180. So basically, and if you haven't figured it out yet, everything in here is either going to add up to 180 with like any two angles together. So like 1 and then pick any other angle. They're either going to add up to 180 together or they're going to be identical. There are only two angle measures in this whole thing, and those two different numbers add up to 180. All right. So here is our first like problem that we're going to do with this. So you don't need to draw it to scale, so don't worry about it. I'm not going to try to draw it to scale. two parallel lines. All right, here's my transversal. Just pick any of these that look obtuse. So 1, 2, 3, 4, 5, 6, 7, 8. Let's say that angle 1 is equal to 118 degrees, okay? If angle 1 equals 118, find all other angle measures. All right, so we got 1, 2, 3, 4, 5, 6, 7, 8, right? And we know that 1, hey,